Hey guys. All right, so quadratic equations and discriminants. I'm hoping that based on my notes video, you were able to at least fill this in, and you should have gotten x equals -5 here, x equals 4 plus or minus the square root of 160 divided by 8 here, and x equals -2 plus or minus the square root of, -284 over 18 here, okay? If you had trouble with the quadratic formula part of this, please email me and I will make another video for that, okay? So this means our discriminant comes from this part underneath our quadratic. So on this one, we should have gotten 0. On the second one, we would have gotten 160. And the third one, we would have gotten 284, okay? All right, so down here on the questions, it says compare a number of solutions for each quadratic equation. Well, in the first one, we just got x equals -5. So that was just one solution. So on the first one, we had one solution. On the second quadratic, well, this breaks down into 4 plus the square root of 160 divided by 8 and 4 minus the square root of 60 divided by 8, 160 divided by 8. So that's two solutions. We have two solutions. And then the third one, also, this would break down again into plus and minus. So we have two solutions here. Okay, so then we want to describe the differences between the discriminants. Well, the first quadratic 1, we have 0. The second quadratic and then the third quadratic are different because this is a positive and this is a negative. So we have a positive answer here and a negative answer here. Okay, so based on these findings, what do we notice? Well, if a discriminant has less than 0, which means it's negative, then the quadratic will have how many solutions? 2. We had 2. But more specifically, we ended up with this square root of -284. And I kind of want to take a second to talk about this. So when we're taking the square root of something, we're thinking about what did we multiply by itself to get this number. So if we had a positive number multiplied by a positive number, we would get a positive answer. And if we had a negative number multiplied by itself, which would be also negative, then we would also get a positive answer. So we have this issue with this negative number being under the square root. We can't multiply two things together and get two of the same thing together to get a negative answer. So this is not just two solutions, but this is actually two non-real solutions. So we're not going to get a real number. This is where we get this imaginary letter I from, okay? So this is just not two solutions, but it's two non-real solutions. All right, so then the next one says when the discriminant is equal to 0, the quadratic equation will have, well, the first one was equal to 0, and we had one solution there. I guess I can box this in so they look the same. So we had one solution, and it was a real number. It was -5. So I'm going to rewrite this as one real solution. Okay. Then we had when the discriminant was greater than 0, which means it's positive. And here we had two solutions, and that's a positive number underneath our square root. We can take the square root of that. It may not be a pretty number, but we could take it. And so again, we have two real solutions. We can think about these numbers, okay? So this discriminant comes in handy as we are moving forward in this unit because it will help us know how many times is this parabola going to cross the x-axis? How many solutions am I looking for? Do I need to have one? Do I need to have two? If we're taking a multiple choice test like the ACT or SAT, and we can use our discriminant, maybe we only have one answer choice that has one solution. we can just determine the discriminant and know, well, that's my answer because it's only got one solution. So this can be helpful in a number of different ways, and we'll see that as we move forward in this unit. All right, so then number 4 and 5, I think this is where most of you are struggling. Given the equation f of x equals 5x squared plus 10x plus c, what values of c would make the quadratic equation have no real solutions? So we have, this is what we're looking at, non-real solutions. And this means that we wrote it out here verbally, but this means that our number is less than 0, our discriminant is less than 0. This would be equal to 0 on B and greater than 0 on C. So my discriminant, that b squared minus 4ac, needs to be less than 0 for it to be non-real. So let's go ahead and plug these values in and solve for C. That would be, let's see, my A is 5, my B is 10, and my C is, we don't know. So I'd have 10 squared minus 4 times 5 times C needs to be less than 0. So I have 100 minus 20C is less than 0. So I'm going to subtract 100 from both sides. And I'm going to move it up here. So I have negative 20C is less than negative 100. I can divide by negative 20. When I divide, that means I have to flip my symbol since I divided by a negative number on both sides. Negative 100 divided by negative 20 is 5. So what we're saying is the values of C that would make the quadratic have no real solutions are any number bigger than 5. So we could have 6, we could have 8, we could have 152, we can have 367, any number, right? But this is the answer I'm looking for right here. All right, so then we can do the same thing. We want to know a B value for 2 real solutions. So now we're talking about when our discriminant is bigger than 0, so greater than 0 because it's positive. And we have an A value of 6, a B value of we don't really know, and a C value of 15. So we would have B squared minus 4 times 6 times 15 is greater than 0. So B squared, let me do this in the calculator really quick because I don't want to do that in my head. 4 times 6 times 15 is negative 360, greater than 0. So B squared is less than 0. Sorry. Wow, I just was making stuff up. Okay, I'm going to add, let me back it up a step and write down what I'm doing here. Add 360 to both sides. So I have B squared is greater than 360. So now I can take the square root of both to undo that square. So I'd have plus or minus B is greater than the square root of 360. We're just going to leave that unsimplified for now. But it shows here that we have a negative B. So that means I don't really care about the positive. So we'd have positive B is greater than 360. But I'm worried about the negative B is greater than 360. Because that's what it's telling me. I have a negative B value, right? This is negative B. So now I want to get B by itself. I'm going to divide by negative 1. And B, I have to flip my symbol because I divided by negative, is less than the negative square root of 360. So this is where my solutions would fall. One of these values, okay? All right, well, if you have any more questions about this, please reach out and let me know. Like I said, if you need help on using the quadratic formula up here at the top or finding the discriminant, let me know. I'll make another video. I just didn't want to make this one too long. All right, y'all have a good day.